Many people have noted that the Earth is rather special and had all these conditions listed there in order to allow life to evolve. But I think we shouldn't focus too much, because we have clearly evolved in this environment, in symbiosis with it, and to say that isn't it amazing that we match our environment so well is like saying, isn't it amazing that your legs are just long enough to reach the ground? It's not really. It just works out that way. And so perhaps the life on Earth has evolved to fit the Earth, and maybe there could be life elsewhere. There could be balloon-like creatures floating in dense atmospheres and Jupiter-like planets. And of course, science fiction writers have many other ideas. And incidentally, it's far better, I would tell my students, to read first-grade science fiction, like Arthur C. Clarke's, than second-grade science. It's more interesting and no more likely to be wrong. Well, we just don't know how likely it is a simple life exists. And even if simple life were common, it would be a separate question whether it would be likely to evolve into anything we would recognize as intelligent or complex. Of course, some people think they know already. There are, of course, people who think they've been visited. I get letters from people who've been visited or abducted by aliens. And my response to such letters is to tell the correspondents to write to each other. That's not the way. Or to say to the correspondents, what a pity that having made these tremendous efforts to traverse interstellar distances to come here, they had the bad luck to meet a well-known crank. They explored a few cornfields, made some corn syrup and went away. So perhaps we will one day detect the signal of intelligent life. I don't think we have it. And of course, as you probably know, there are people who are using radio telescopes to look for evidence for some artificial signal. And I'm in favour of these projects, because even if the signal were very boring, like a list of prime numbers or the digits of pi, it would carry a momentous message. Concepts of logic and physics, if not consciousness, weren't limited to the hardware in human skulls. What would we talk to these people about? We would have a common culture, because even if the aliens live on planet Zog and have 7 tentacles, they'd be made of the same kind of atoms as us. They'd gaze out, if they had eyes, at the same cosmos. They'd trace their origins back to the same Big Bang. But of course, even if we could make contact, any aliens would be so far away that signals would take many years to travel each way. No scope there for snappy repartees. On the other hand, perhaps such searches will fail. Perhaps there's no galactic community for us to plug into. Moreover, even if intelligence were widespread, we may never become aware of more than a small and atypical fraction of it. Some brains may package reality in a fashion that we can't conceive. Others could be living contemplative lives, doing nothing to reveal themselves. Absence of evidence wouldn't be evidence of absence. Because the only type of intelligence we could detect would be one that led to a technology that we could recognize. So much for life. Let's now expand our horizons further and go back to the simplicities of the inanimate universe. If you look at 2 million light years away from the Earth and look back at our galaxy, it would look something like this. This, of course, is Andromeda, our nearest neighboring galaxy in space. And it's a spinning disk, viewed obliquely, where about 100 billion stars are orbiting around a central hub. And if we were looking at our galaxy, 2 million light years away, it would look like this, with the sun somewhere out towards the edge. And here's another galaxy, the Whirlpool Galaxy. This is another disk. See more or less face off. Well, how can we understand, as astronomers, something about these galaxies? We can't do experiments on them. We can't study them in a lab. But we can do experiments in the virtual world of a computer. We can ask what would happen if we crashed 2 galaxies together. here's what you find if you do this in your computer. Two galaxies crashing together, and what happens is each of them raises gravitational tides on the other, and you end up with a rather messy system like that. Well, that's what would happen if two galaxies collide. You then look actually into the sky, you see things like this. And you can plausibly infer, on the basis of experiments in our computer, that what's happened here is two galaxies have got close, each has raised these tidal wisps on the other. And it's by lots of modeling of this kind that we can gain some confidence in how galaxies are structured and what they're made of, even though we can't do experiments. We can observe large numbers and we can model a virtual universe. We can also study many galaxies. This shows the distribution in space of the nearest 3,000 galaxies. They're grouped in clusters. And if you look still deeper, here is about 200,000 galaxies. And the point here is that obviously they thin out at distances, but you see here the galaxies are grouped together into clusters, but they spread out into space as far as you can see. Now, one thing that we've known for a long time is that when you look at distant galaxies, they're moving away from us. The further away they are, the faster they're moving, as indicated by these arrows. And this is the so-called Hubble law discovered by Edwin Hubble. Heavy smoker, as you can see there. Now, contrary to what you might guess first, this Hubble law doesn't imply they in some special central position. Imagine in this infinite lattice that all the rods were to length at the same rate. Then if you sit on one vertex, you would see the other vertices moving away at a speed proportional to the number of intervening links. Everything would scale. And that's quite a good way to imagine the expanding universe. Imagine that the galaxies, or cluster of galaxies, all linked by rods, and the rods all lengthen. And you see the expansion wherever you sit in the universe. But there's one feature which isn't brought out by that diagram, it's better brought out by this. This is another Escher picture called Angels and Devils. And because light travels at a finite speed, if you look a long way out into space, you look a long way back in time. And therefore, if the universe is expanding, you look back to a time when everything was crowded closer together. So if you look out into space, back along your so-called past light trail, then what you see better resembles this thing. You see things more closely crowded together, the further away you look. And we can look very far away. This shows tracings of the spectrum of light from three very distant quasars. I won't go into detail, but I want to say that the strong peak there is the strongest line emitted by atomic hydrogen, called light and alpha. And in that, this is a far ultraviolet, 1269 angstroms. But in these quasars, you see it at 9,000 angstroms, the red end of the visible spectrum. The wavelength is stretched by about a factor of 7. And this indicates that the universe has expanded in scale by a factor of 7 since the light had set out. So looking back to a time when the universe was much more compressed than it is now. And we can look very far away and find huge numbers of objects. This picture shows a patch of sky so small it would take 100 patches like it to cover the full moon in the sky. This patch would look just blank, looked at through a small telescope. But with a very big telescope, you see these hundreds of smudges. Each of these smudges is a galaxy. Many of these galaxies fully equal to Andromeda or our own galaxy.